peeps, it's Julian here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with some geometry. It's taken from question 5 of the Maths Paper 2 IEB 2019 Supplementary exam. So, A is prove the theorem that states the angle subtended by a chord at the center of a circle is twice the size of the angle subtended at the circumference. So it's basically need to prove that this angle O over here is twice as big as B. So to write that down for 1 mark, we need to prove that AOC should equal 2 times the angle of ABC. So that's 1 mark. So to start this proof, we need to construct 2 triangles. So if we draw a line that goes through the center, we now have 2 triangles. And we form that we have an angle O1 and O2 and B1 and B2. And that's another mark for your construction. So the first thing we need to state is that angle O1 will equal angle A plus angle B1, and this is because of exterior angles of a triangle, and that's your reason. So we know that A1 and angle A and B1 are equal. We also know that angle A equals B1 because from the center of the triangle, this line here are radii, so the reason will be radii, and the fact now that because it's radii, it's an isosceles triangle, and an isosceles triangle means that B1 equals angle A. So then therefore we can then say, okay, your angle O1 should equal, substituting A in for B, it should be B1 plus B1, which will equal, this is a 1 by the way, equal 2 B1s. The same thing happens in the other triangle, so we know that angle O2 will equal angle C plus B2, and we also know then that, and this is the reason, remember to always give your reason, exterior angles of triangle, and then same thing as angle C then will equal B2 because of isosceles. So therefore we've got that O2 equals, substituting C in for B2, so now we've got that it's 2 times B2. So, and then we also know that this angle O, so the entire O, which is obviously O1 plus O2, and we can then substitute in for what we just found out, that O1 would equal 2 times B1 plus 2 times B2, which equals 2 times B, the whole angle. And so that means O equals, and which is exactly what our required to prove statement is. So we can just write down, therefore angle AOC should equal 2 times ABC. Okay, moving on to the next question. Given us a diagram with ST, and they told us that ST is a common chord between 2 circles. and various information about the diagram. And the question is just calculate the size of angle T2. So first of all, we can get what the angle of S2 is. We know that the angle of S2 equals 55 degrees because we know that it's told us that ORS, so that's ORS is 55, and because this line is part of the radius, as well as that, it's formed an isosceles triangle, so we know that S2 should equal R, and the reason here would be again radii, and also of course that the fact that it's an isosceles triangle. Then we also know that we can see here that the full angle of S, so S1 and plus S2, so S1 plus S2 must equal 90 degrees, and the reason being is that angles in a semicircle equal 90 degrees. So your reason here is angles in a semicircle. So therefore, we can then conclude that angle S2 should equal 90 minus 55 because of our previous statement, which means it equals 35 degrees. And then finally, we've got this triangle over here, that TOS, and we can see that this is a triangle in this circle that they've told us where that this TV is a tangent of the smaller circle, which means we can use the tan chord theorem and conclude that angle T2 should also then equal 35 degrees. And as I said, your reason here is your tan chord theorem. And that is the answer to B. And moving on to C, they've given us another diagram, and they've given us a circle with points A, B, C, D, and G all on the circle, giving us some more information and ultimately asking us to find the size of angle AGE, which is over here. So to start off, we can first of all see that they've told us that this line ED is the tangent of the circle. So that means that this angle here, which is equal to 80, must also be equal to this angle here because of the tan chord theorem. So angle ABD should equal 80 degrees because of the tan chord theorem. They've also shown us that they've given us this angle A here equals 32, and we should equal this angle, which would be B2 if that's B1. So we know that the angle DBC should also equal 32, and the reason being is that angles in the same segment are equal. So angles in the same segment. Cool. And then finally from that we can see that the angle that we're looking for, which is angle AGE, should be equal to the angle of ABD, which is this one, and DBC, their sum, because of the reason exterior angles of a cyclic quad are equal to the sum. So basically we can write that angle ABD plus DBC are equal because, as I said, exterior angles of a cyclic quad. So if we just substitute those in, we get that angle, it's not there, AGE, emphasis on the G, should equal 80 plus 32, which gives us 112. And that's the final answer. Before I go, I'd just like to give a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more awesome and epic tutorial videos just like this. If you can't find your answer to your question, be sure to send us your question and we'll respond with a personalized video just for you. And until next time, stay epic.